Good afternoon, ladies and gentlemen. Thank you for joining the third episode of Tenant Talks, a new web series we launched here at COVE just recently to sit down weekly with a new member of the COVE community and understand all the interesting projects and products that they're up to. Some housekeeping items before we start. At any time throughout the presentation, please feel free to ask questions using the Q&A or the chat function at the bottom of your screen. I'll be happy to ask those questions live to Noah, who is our guest today. So I'm very pleased to welcome Noah Stevens. He's the co-founder and lead developer at 3D Wave Design. Welcome, Noah.
Hello, nice to be here.
How are things going?
We're going well.
Nice. So as we usually do with this series is jump in and chat a little bit more about you as a person, your experience, and then kind of what led you to starting the company 3D Wave Design.
Yeah. Well, it's actually a really interesting story because my background is actually in film and television. I worked in film and television on set, and then I got into editing a little bit, and then ultimately into 3D animation. And with my 3D animation projects, I had been doing a lot of coding and scripting for task automation and sort of enhancing our 3D animations. And as I was slowly on my way out of the film and television and commercial scene, I actually partnered with my father, Barry Stevens, who's another co-founder, and my wife, Lena Ali. Her background is actually in journalism, and my father's, he's an electronic engineer. So we've sort of pooled our resources together and our backgrounds, and we had a pretty unique product offering. Essentially, we'd come in as technical consultants, and we would help local industry and industry abroad look at pain points with their products and then help them market those products. So traditionally, a lot of digital media companies, they get a script handed to them and they sort of make the video. Well, we would actually work on building everything alongside the client and then giving them a product that they could use for distributing on the web. So like a 3D animated video showing their product, or they could take to a conference abroad. And so we had worked with many companies, GN Plastics, Stelia Aerospace, and the like. And we had a knack for doing this kind of work. And then over the years, we ended up talking to a fellow named Tim Webster from AGRG. It's the Advanced Geomatics Group in Middleton with NSCC. And we were looking at visualizing climate change data and doing 3D services for that. And we saw amazing potential in how this data was collected with LiDAR technology. And the province has basically flown LiDAR data for the entire province of Nova Scotia, and I think New Brunswick as well. And the data exists, it's very high resolution, but the way that data was displayed wasn't really in technical lockstep with how it was collected. There are ways you can visualize photogrammetry and LiDAR online through web software or native software. But I found that it ran slow on commercial computers. It was really meant for the scientists to analyze the GIS and digital elevation maps. So we basically wanted to go and apply our skill set that I had mentioned, our communication and technical backgrounds, and look at developing a product that essentially broke down the technological language barrier and helped people understand very complicated data that was normally reserved for PDF reports. So engineering firms and the like would basically do research and then write a 120-page report with basically 2D maps printed on a PDF page. And we were wondering, is there a way that we could take this data, make it more relatable, use or build, which is what we're doing, technology that's very akin to Google Earth in the 3D, very user-friendly, but also relay climate change data effectively so people could better understand the risks and how to properly mitigate. So over the years, we've been developing our own intellectual property in terms of building mapping applications, and then also core technology for visualizing and running simulations and processing LiDAR. So.
That's really amazing. Making these tools more accessible is really key to adoption, correct?
Absolutely, yeah. We're all about democratizing information. So at the same time, we try to make this complicated data easy to understand for the end users, such as municipalities or citizens. But at the same time, getting access to and visualizing the data, we want to make that even more easy as well.
That's fantastic. So these data points, obviously, there's work into collecting them, but I guess there's other municipalities, other groups around the world that are collecting this type of data that you could easily build products off of.
Absolutely, yeah. No, we've been primarily working with LiDAR data within the province and the digital elevation models that they've been generating. However, we have sampled from outside of the country, and it is quite expandable. Yes, and actually, we had made some massive headway for processing the LiDAR and generating these 3D models on our desktop work computers for our own workflow. But we're in the process of currently building these 3D models real time in a browser. So essentially, a user could go on to GeoNova, which is where they host all of the LiDAR data for the province, download a LiDAR tile and drag and drop it into the browser, and within seconds construct a 3D model to better look at and better understand what they're looking at, like the terrain, so to speak.
Fantastic. That's really it's promising for the future of your company, but also promising for bringing this information to people to make better decisions.
Hopefully, yeah. Hopefully.
So I guess maybe we can jump in now and check out some of these demos so people can kind of visualize exactly what you've been speaking about just now, and see how easy these tools are actually easy to use.
Yeah. If you're ready for me to share my screen, I can do that.
Absolutely.
Okay. So, are you able to see my screen?
Yep.
Perfect. So this is one of our earlier projects that we did for the Acadia Band. This particular reserve is Medway. So we downloaded the LiDAR data from GeoNova, we processed it on our end, and now it's running in the browser. What I'm really proud about too is that this 3D that you're seeing is in real time. I'm manipulating it, and it's very performant. So I could essentially run this on generations or older generation Android and iPhone devices. So anyone with a link can click on this, find it, and interact with it. Now, if I want to show you how to sort of manipulate the maps, we have all these pins here. It sort of gives context to the area. So I can click on the band office, and I get an idea of what I'm looking at and other resources here. But what's also really cool is that I have a slider down here that allows me to adjust the water levels for this river. So this river in particular is actually being monitored by NS Power. But what we're offering this community is a hypothetical. So if the water was to raise by several meters, what would the impacts be? So I can do that right now. I can start raising the river, and you can see it flooding inland here in the Greenfield Elementary School. But more importantly, you can actually see the impact for the reserve. So I can actually toggle the reserve land. Now, you may think that this area is relatively protected, but they were looking at building in through here. So they wanted to basically see if how at risk they were for fluvial rise. So we can actually, with this technology, classify buildings and trees right in the browser. So I can toggle the trees and the buildings off. And you can actually see the land here, which is still textured, of course, is being affected by the river raising and lowering. And so also, we've built into this particular map the ability to give the people resources so they can access local weather. They can get Public Safety Canada information for mitigation. We've also included videos that we've shot. This one's embedded in the application. It's a climate change adaptation plan that we did with Heather McKenzie-Carey, an EMO person, that helps people understand historical adaptation, indigenous adaptation. So I won't play the whole thing here, but you can just see that People have access to videos within this application as well. And I'll exit out of this. And another really cool thing that we have in here, which I want to show off, is we have fire simulations, which we're currently developing. And what you're seeing here is one of our earlier prototypes. So essentially what we do in this application is we've been able to look at the point cloud, figure out what's grass, what's trees, what's buildings, and then calculate burnability. And so here I can take my mouse, I can select a location where I want the fire to start, and I have all these variables that I can play with. Now, we're working off of Byram's equation, which basically factors in heat, convection, burnability, all of this stuff. And you can play around with the variables here with the sliders. And I'm going to do that here. I'm going to increase the wind speed. I'll leave the dryness, and I'll start the fire. Now, what you're seeing here isn't a true to life simulation in the sense that we have disclaimers basically saying that everything you're seeing is hypothetical, but this is hopefully going to be a tool, an emergency management tabletop tool for EMO professionals, so they can run through scenarios with the people of this community when they're having their town hall meetings, for example, so they can better understand what's at risk, what could be closed off from a fire, and what have you. Now, you can see here, we're starting to fan out. And in real time, I can actually adjust the wind direction, and I can increase the wind speed. So this is actually adapting to the variables that I'm changing in real time. So you can see it's starting to spread out more this way.
In a Chrome tab too, not even a local.
Yes.
A local render.
Exactly, and I want to emphasize that our main focus, or one of our main focuses, is performance in the web, because this is ultimately how we get our data in the hands of people. You don't have to download a thing. You just click on the link, and this will run on older generation computers, phones, and tablets. So I'm going to pause this if anyone has any questions. And I'm going to bring up another demo here. And this is one that we did early on. This is one of our first demos when we were developing the technology. And this is for the town of Mahone Bay. And so with this tool, you can actually toggle infrastructure and see what's at risk. So you see these lift stations here. These are lift stations for the sewer. And so as I adjust the tide and I adjust the storm surge, you see they get breached. And this is all data from GPS locations and the actual height of the lift station boxes and all that stuff. So as you're getting your data from Environment Canada, you can put the data in with the water levels here and get an approximation of what's going to be affected. And what's also really cool is that you have access to historical information. So people can better contextualize what has happened in the past with what is being predicted. Because you say a meter to somebody, and I like using this example, people will visualize a meter in their head as a number, but they're not actually thinking about a meter in real world space. But when you're able to actually visualize that, you get a better sense of what's truly at risk.
That's fantastic. I see that the brewery is still safe. So
yeah, absolutely. And so what you've seen from these two demos, this is data that was processed. We processed it on our end, but it was collected from GeoNova. Now we actually flew data in partnership with NSCC. Hence why the detail and the texturing is a bit better, because this is a custom flight. And so this is for the pond reserve. And we can actually have two separate bodies of water that we can adjust. This is the water from Lake Rosignol flooding. And then once it breaches the dam, we can visualize the Mersey River. And we can toggle the reserve land to basically see if that's being impacted, the roadways and what have you. Yeah, and these are the completed products that we have finished late last year and early this year. I'm going to stop sharing my screen here. But that's essentially a good look at what we've developed so far. But we've actually, we're working with the town of Lunenburg on visualizing some engineering data. We're working in partnership with CBCL, and we're looking at basically what would happen if the waste treatment plant there was flooded, and what mitigation that they can what mitigation they can put forward to protect the plant. And so we're actually going to be able to visualize the storm surge, how the plant would be affected, and then also the remediation. So in real time, placing in a berm or a seawall, for example, and watching that water basically not be able to flood the area. So people and shareholders and citizens can see what can happen if they invest their money into the remediation or the protecting the wastewater treatment plant. And that's also going to be using new technology that we're currently working on right now that does not require us to build these 3D models on a computer and then upload them online to be viewed. These 3D models will be parsing and reading digital elevation data from LiDAR and building the 3D models instantaneously. And the exciting part about that for me is that makes our applications infinitely scalable.
That's awesome. So then you could easily work with partners all around the world to quickly get something off the ground.
Absolutely, yeah. And as I was mentioning, we have a two-pronged approach. Essentially, as a company, we're offering our services to visualize climate data per municipality or indigenous reserve. But we're also looking at creating this technology that could potentially be used by other firms in the future. So we're not at the point where we're ready to license anything, but we're working towards that.
Fantastic. More to come in 2020 and further into that as well. I noticed in a lot of your simulations, you had highlighted the reserve land in some of those simulations. Can you explain to the audience the indigenous side of things and how that impacts your business?
Yeah, absolutely. So we're an indigenously owned and operated company. And with that, we are in talks with a lot of indigenous bands. I'm from Acadia Reserve, so is my father. So they were actually one of the few people to sort of champion this technology, because when you're first to market on something, people can sort of hesitate on early adoption, but they understood that this technology was really beneficial for them to understand what was at risk. And so they have been supporting us since the beginning, and they've been really great partners for us.
Fantastic. And I guess the mission of visualizing all of these impacts is also is kind of right at the very heart of some of these core issues. So
absolutely, yeah. I think if COVID has shown us anything, it's that communication is paramount. And if people don't understand what's at risk, or they don't understand the numbers that are being presented, that hopefully technology like this will be able to help people better understand what's at risk if we don't take action. And so there's one thing to do, flood predictions for the next 50 years and do a report, but there's another thing to actually be able to put that data in and quite literally see what is at stake or what's going to be affected.
Absolutely. And I guess one of the historical big challenges of climate change kind of mitigation and techniques has been the getting the buy-in from the larger community around what some of these big projects might look like and what they might entail. And that visualization piece is kind of critical to and helping get that.
Yeah, and like I had mentioned about the Lunenburg project that we're working on, we're not only showing what's at risk, but we're able to visualize the remediation and what can be saved by putting in a seawall, for example.
Fantastic. What kind of trends are you looking at and kind of adapting to or looking forward to in the next year or so that you guys can capitalize on?
Yeah, well, I do think people are taking climate change a lot more serious now. And I think with, us being in the middle of a pandemic, people are realizing that our infrastructure and our societies are a little bit more fragile than we think. So I'm hoping that people are going to take what they're experiencing with COVID and have that translate to environmental stewardship, and realize that we cannot continue on the course that we're on. And that with that, we'll hopefully get engaged a little bit more on creating these projects that municipalities and or the federal government could share with people to basically go in and visualize these climate effects.
Fantastic. That's really, really powerful. Is there anything maybe from an audience perspective that you would like help on? Maybe it's finding connections in some of these areas, kind of leaning on who might be watching and who may watch later to kind of help out.
Yeah. I think engagement at this point is very important, because it gives us an opportunity to sort of tweak the product development, because a lot of what you have seen has come from us talking to municipalities and asking them what their pain points are, and then us coming up with a solution. So now that we're sort of, we have a big chunk of our development done in order to make these maps. I think in order to further develop the capabilities, now would be a great time to talk to people and say, what are you having issues with? What are you having trouble communicating with? And then building that into the next iteration.
Awesome. There's probably even some data sets that you could easily integrate with some of these solutions that maybe you haven't thought of yet, that maybe someone's had a burning issue and they need this type of tool to integrate. So that's possible as well.
Mm-hmm. Absolutely. We were using flood data and the bathtub simulations that you were seeing there as our sort of entry into environmental data. And then it was an ask from a community with the fire simulation that we said, well, can we do this? We looked at the equations that existed. We built a sort of a simplistic system around that initially to prototype. And we realized, hey, yeah, actually you can visualize fire with user input dynamically. Of course, we have to consult with experts to make sure that all the variables are as accurate as they can be. You can't 100% get total accuracy, but it was a good sign that we are very adaptable and we can integrate more tools into our software.
Fantastic. I don't see any questions come in yet, so I'll open it up to questions now, but I guess let's give the audience an opportunity. How can they connect with you? How can they find out more? Where do they go to do that?
Okay, I see a question here. Yes, we do require LiDAR. LiDAR for us is important because you get the relevant height data and elevation data and the fluvial data, depending on where you are, and the bathymetry for our water simulations and even our fire simulations. However, we have and we can integrate photogrammetry into our work. So an issue with LiDAR, for example, is you're not getting color data with the point cloud that we're using to make our 3D models. You're just getting the contours essentially. So we have to stitch an ortho photo that was taken separately by a plane and sort of like drape that over the contours of land. So you're not getting much detail on the side of buildings. But so if you take the elevation accuracy of LiDAR for the simulations and you pair that with the visual quality of photogrammetry, which is sort of what you see in 3D buildings when you're on Google Earth, yeah, you have a really powerful tool because you get more visual detail that way. And we have done that in the past, yes.
Fantastic. Thanks, Bruce, for the question. So if they want to connect, what's your website, social media, things like that? How can they learn more?
Yeah, so we have a website. It's 3dwavedesign.com. From there is a contact page that will get you in touch with my father. We also have a Twitter page at 3dwave, and Facebook. We have a 3dwave design a page as well. From there, you can also send us private messages, and we'll receive that as well.
Fantastic. Thanks so much, Noah. This was really an informative chat, and I think a lot of people liked it according to some of the chat messages there. So I'm very appreciative of your time, and I think it was a really good insight into some of the tools that you've built and kind of where you're going in the future. So thanks very much.
Yeah, no problem. It's very exciting to talk about this stuff, and I'm happy that I can share.
Thanks. Have a great day.
Yeah, you too. Take care.
Just a note for the people watching. Next week we do this all again. I'm sitting down with Niru. She's the president and CEO of Sensor Technology, and that is June 2nd, actually Tuesday, June 2nd at 1 p.m. So looking forward to that.